Hello everyone. In the previous session, we have just listed out what are the various applications of GPT models. Now we shall see three applications in detail. In the first one, I will be talking on text generation using GPT. So what exactly text generation application is? Let us quickly look at all these things. So under text generation, what happens is the model involves with a process of predicting some sequence of words whenever we are giving a prompt. Say for example, I give the cat sat on, I stopped. Next word should be the, then next word should be whatever is the context. The cat sat on the maybe mat or a chair or something. The word should be predicted based on the context and the general usage of objects. So, the text generation process is the model, what it will do is first it will try to understand the patterns of sentences which are formed using the language with which it is trained. The model is trained with a language. Now you are trying to fine tune it for text generation. It has to generate what could be the next word in a specific sentence. For this, what is the requirement? We are supposed to give a prompt. Prompt is nothing but the initial kind of, can you give me information on Mahatma Gandhi? That is the prompt for it to generate the content, right, to generate the text. So first of all, it has to have a prompt, given input or prompt. You are supposed to give a prompt based on which it will try to generate the content or text. So this is the application of text generation. For that, what is the first step involved in text generation? Input processing, or we also call it as prompting the model. As we have discussed in the introduction, we need to submit a prompt to the model. So input processing, what do I have in this? First one, user input. The text generation application begins when the model is given a prompt. What kind of prompt should we give? It could be a sentence, it could be a question, or it could be a keyword, anything. Whatever we are giving in order for the text generation, that initiation is called as prompt. This prompt serves as the seed from which the model is trying to generate rest of the text. So first user input should be given, which we are calling it as prompt, which acts as a seed for text generation. What is the next step in that? In input processing, user has given the input. The next thing is tokenization. What do we mean by tokenization? The model first breaks down the given prompt into smaller tokens. So here suppose we are trying to give a prompt and that prompt is given in the form of a text that will be broken down into smaller units like words, subwords, and we are calling them as tokens. Sometimes the token can be as small as a single character. For example, I have given the sentence, Gen AI is awesome, right? This is the sentence I have given. What could be the tokens in this? Say for example, I am taking word as a token. How many words do I have in this sentence? Gen, space, AI. So space will be taken as a separator for words. So it will try to break my sentence into Gen, AI is awesome and the exclamation character. So whatever sentence we are trying to give as prompt, that will be broken down into tokens. What is the level of tokenization? It could be a word, it could be a subword, or it could be as finer as a character. After that, second process is, what is the second step in the process of text generation? Context understanding and encoding. So first of all, I should understand in which context you are asking a particular text generation, right? So contextual encoding is the first process in this. The GPT model processes the input tokens using its neural network. Because it has to understand the context, it has to have neural networks. Otherwise, it cannot understand, which is based on the transformer architecture. So, under transformer architecture, we have the concept of encoding. So, it uses the transformer architecture. What is the transformer architecture helping it? In order to understand the relationship between various tokens in a sentence and understands their context in the sequence. And in order to give weights and in order to see the importance of each and every token, it uses the self-attention mechanism. Then after the contextual encoding is done, hidden states. As the input is passed through multiple layers of the neural network or transformer, the model starts generating hidden states. What are the hidden states? They are the numerical representations of the inputs. The third step under text generation is token prediction. Under token prediction, what it will do is autoregressive generation. What is the autoregressive model under GPT do? What it does is, first suppose I have given the cat sat on. I just stopped there. The cat sat on. This is the seed for it. Then it will build the next word. Say for example, it has generated the word the. The cat sat on, that was the first seed or prompt I have given. It has predicted the next word to be the, generated that. Now for the next step, what will be the seed? The cat sat on the. So the newly generated word is also added as a prompt for the next word. Suppose the next word predicted is mat. For the next sentence or next word generation, what will be the prompt? The cat sat on the mat. So, every word that is generated will be added to the existing prompt, and that acts as a prompt for the next sentence generation or next token generation. This we call as autoregressive model for text generation. Say for example, the weather today is, I stopped the prompt there. The model, suppose it has predicted as sunny, right? For the next one, then continue generating more tokens like and is the word. So, sunny and what else it will generate? Warm, until it forms a coherent sentence which has got some meaning. Now see the sentence finally generated. The weather today is sunny and warm. So here if you observe, I did not misspell the sentence with two ands. This and also is to be generated. So I have put it in double quotes just to make sure it is not the connector, it is the word that has to be generated. So first time the prompt was the weather today is. Next it has generated the word sunny. So for the next sentence or next word prediction, what will be the prompt? The weather today is sunny. This will be the prompt. Then it has generated the token and. Then for the next token, what will be the prompt? The weather today is sunny and. Next token generated is warm. Still if you want to continue for generation, this entire sentence will be a prompt for next token generation. That is how autoregressive model is used when we are going for token generation. Now sampling and temperature. Whenever you are trying to work with token generation or next word prediction while generating text, the GPT uses various sampling methods. It doesn't always pick what is the most likely used word. As I told, the cat sat on the, generally we use the word mat. So GPT doesn't use that generally used words and will not predict them. It will try to use various sampling methods. So what could be various sampling methods in general? It could be a greedy sampling, top K sampling, top P sampling. So what is greedy sampling? The model always selects the most probable next token. So, in this the deterministic approach will be used, but it can lead to a repetitive and predictable. As I told, the cat sat on the, what is the most probable word which is always used? Mat. Cat sat on the mat, because I wanted a rhyming thing. Cat sat on the mat. It will fill the next word as mat, because that is the most generally used and most commonly used. If we are trying to predict, if the model is trying to predict most commonly used next token, we say the model is using greedy sampling. Otherwise, what is the next option? Top K sampling. What could be the option here? The model samples the next token from the top K most probable tokens, introducing more variability and creativity. The cat sat on the, I might have given a chair to the cat. There could be a couch for the cat, or the cat is sitting on the lawns. So, cat sat on the, what are the options now? Chair, couch, lawns. So, top K. Among these three, any one of the word can be generated. If GPT is using such kind of sampling, we say it is using top K sampling. Top P, the model considers the smallest set of tokens whose cumulative probability exceeds a threshold. So, we try to say use a specific smaller set, do not go for a generalized set, go for a smaller set, and I want to have 90% of the time that will be the particular word. So, suppose that threshold is provided, the model uses that top P sampling, for which you are specifying the nucleus, what is the threshold value. Under top K, you do not specify any such threshold value. This is the difference between these two. Then after sampling, you should also specify temperature. Temperature does not literally mean the heat or the warmness in the environment. Temperature here is the level of randomness during prediction. A higher temperature, that is approximately equal to 1, makes the model more creative and diverse. So, we say we have increased the temperature. That means the randomness, level of randomness also increases, and it will try to predict some creative word which is not generally predictable easily. On the other hand, suppose you have given a lower temperature in the sense the level of creativity or level of randomness is reduced. Level of randomness is reduced means you are trying to have a deterministic word. So, you are trying to specify what kind of sampling and what kind of temperature. Then iterative generation. After generating the first token, as I told, that token will be added to the input, and the iterative process of generating the next token, add it to the input, generate the next token, keeps on iteratively. And the model stops generating when it reaches a predefined end of sequence token. In my example, the cat sat on the mat, I put a full stop. Maybe that would be the end of the token generation. Otherwise, sometimes it stops when it reaches a maximum length limit. Most of the time, generally it is 1000 tokens. That is the example, right? Depending on what type of application we are trying to use. Output text. Once the model completes the generation process, sequence of tokens converted back into human readable text. What do I mean by human readable text? It has generated individual tokens. Now it has to put them into sentences, paragraphs, punctuation, where to use uppercase letters, where to use lowercase letters, etc. It will try to do that conversion into human readable text, which we are calling it as detokenization. Tokenization, a sentence broken down into tokens. Detokenization, individual tokens are combined in order to form sentences and paragraphs. The final output is the generated text, which can be a sentence or paragraph or an article or a long piece of content depending on task specification. Example generation, just quickly look at. Simple example with the prompt. What is the prompt we are trying to give? Once upon a time in a small village. This is the prompt I have given. So, the prompt is taken and the model processes the prompt and it understands that this is the beginning of a story. This is how generally the stories begin. It will try to generate the first token as there. Now, what will be the next prompt? Once upon a time in a small village there. This is the prompt for next token. What is the second token it is generating? Lived. This continues until you get a meaningful sentence. Say for example, once upon a time in a small village there lived a kind old man who helped everyone in need. Makes meaning, right? Makes sense. So, such kind of coherent sentences are generated and then the model stops generating the text. Suppose you told once upon a time in a small village, use this and generate a story of an old man, right? That was the prompt you have given. It will start generating until the story gets completed. Each word is generated based on its likelihood given the preceding context until the story is complete. This is how the text will be generated. What are the key components of text generation? Quickly see this one. Self-attention is needed because we are trying to identify which word is related to what with what importance. Positional encoding, transformers do not have inherent knowledge of word order. So, positional encoding should be given. Autoregressive nature, step by step, adding the next tokens to the prompt. So, summary, text generation in GPT is an iterative process which starts with a prompt and uses the sampling methods and then the temperature levels to decide the randomness and then keeps on generating the text. Next session we shall see text summarization. Thank you.